So, I will start with a part 1, and this is still an overview. Introduction to electric vehicles and vehicle subsystems. This part will be done entirely by me. My email ID is also given. In case you have any questions, please write to me. And introduction to electric vehicle and EV subsystem requirement. This is what we will do in the course 1. What will we do? This course part 1 consists of 3 chapters. The first chapter will be on overview of electric vehicles. I will get into more details of that in a short while, but it will give you a good introduction to electric vehicle. Why electric vehicle? What is there in electric vehicle? And then specially contextualize it for India. Overview of EV in India. What is the state of EV? What are the key concerns when you are talking about EV in India? The first part, the introduction part, is common to anywhere else, but the second part, 1B part, 1.2 part, overview of EV in India, which will be specifically for India. Then we will get into chapter 2. Chapter 2 is vehicle dynamics. This could have been a course that you would have studied in mechanical engineering, in automotive engineering, anywhere. It is actually an overview of how does vehicle move, what is the vehicle dynamics. It is applicable for petrol vehicles as well as for electric vehicles. Conventionally, this course used to be taught for petrol vehicles. I am updating it and bringing the concept. Concepts are very similar, some minor changes to bring in electric vehicles. And here we will start with, if there is a vehicle, whatever with the size, weight, and we know it is moving at such speed, what are the forces acting on a vehicle in motion? That is the beginning, that is the first part. We will specifically look at any particular point, what is the power that is used to drive that vehicle and what is the torque required for acceleration. Very, very important, because finally you have to produce that power and torque. You have to produce this by IC engine in a petrol vehicles, by electric motors and controllers driven by a battery in a electric vehicle. So, understanding of power and torque required at any point of time becomes very, very important. The next will be comparing force and power required for 2-wheelers, 3-wheelers, a 4-wheeler sedan and low end trucks. We will take 4 examples: 2-wheelers, 3-wheelers, sedan and low end trucks. And what is the force and power required at any point of time? Of course, we will also calculate torque, but because we have given that. And then we will introduce a very, very important concept called concept of a drive cycle. A drive cycle is a typical driving mechanism used, or drive, I will not say mechanism, typical drive that is used in a particular city or in rural areas or in a mountainous terrain. So, if you drive it in a certain manner, the issue will be how much power, how much energy is used, and it will be used to compare one vehicle and the other. So, that is the drive cycle concept, and I will get into details of that. The third chapter in this course is going to be on vehicle subsystems, EV, powertrain and accessories. What all was there in a ICE vehicle, a petrol vehicle, internal combustion engine vehicle, and what is there in electric vehicles? What goes out, what goes in, how do you replace one thing by other, and it will of course bring us, starting from a petrol drivetrain or ICE drivetrain, it will come to electric drivetrain. And then we will look at vehicle performance parameters. What are the performance that we need to get to? And therefore, every subsystem has to adhere to provide you that performance. So that we will discuss in somewhat details. And finally, we will also talk about EV auxiliary power. Auxiliary. Now in any vehicle, electric vehicle or petrol vehicle, there are auxiliary. There are auxiliary, for example, there may be a air conditioning system, could be an auxiliary. There may be power brake system. Instead of mechanical brake, there may be a power steering. There may be all kinds of communication systems and control systems. There may be entertainment systems. There may be communication system in a vehicle. There may be motors which will automatically open your windows, close it down. All these are auxiliaries which will require powers. And if it requires power, of course, in a petrol engine, primary drive will come from petrol. Of course, today even they are converted that from petrol engine you actually charge a battery and you drive all these, most of these auxiliaries by electric vehicle, electric current. But of course, some of the auxiliaries is still driven by hydraulic power, which is directly derived from a petrol vehicle. Electric vehicle, everything will be driven by electric. So we will get into this. So all these subsystems will be also looked at, because they all have to be added to this is the amount of power that I require from my battery, and this is what I require from my motor and controller, and this is what my charger has to do. So all these three things will be done by in part 1. Let me get into a little more detail of part 1. This was a very top level overview. What do we do step by step? We start with the internal combustion engine vehicle, ICE vehicle, petrol vehicle. And we then say, take this part, remove this, add this, remove this, add this, remove this, add this, and it becomes electric vehicle. So that part, overview of electric vehicle, we need to get you understanding. Though that terminology for electric vehicles become important, because the rest of the course will use those terminology. And of course, well, associated with all this, you will have to talk about force, torque, speed, power, and gears. Actually, you have to talk about all these parameters, all these things in petrol vehicle as well as electric vehicle. But since we will move from petrol vehicle to electric vehicle, we will reintroduce each of these subsystems, each of these parameters: force, torque, speed, power, and gears. From there, we will sort of say, okay, what kind of motors and controllers are required? So we will give you a quick overview. Detail will be covered in part 3 of the course, the third course, which will be on motors and controllers. Then we will talk about energy source, fuel tank versus battery. In a petrol vehicle, there is a fuel tank where you fill up the petrol. Equivalent of fuel tank is a battery. Just like a fuel tank is a container of petrol, which is the energy used by a petrol vehicle, a battery is a container of electricity. It is no more than a container of electricity, and that electricity is going to be used by the vehicle. And of course, for the fuel tank and for the battery, we have to talk about, therefore, what is the capital cost involved in getting the fuel tank or battery, and what is the operation cost. As you run every kilometer, what is the operation cost, running cost, recurring cost. Normally, you don't talk about much of it in a petrol vehicle because fuel tank is low cost. It's just a container. It's a one-time cost, very low. So capital cost is not talked about. Only operation cost or recurring cost is talked about. You will soon see in electric vehicle it is just the reverse. The cost of the battery is the dominant cost. That's a container of electricity. That is not electricity. There is a container of electricity, and therefore there is a large capital cost. How do you take that into account becomes very, very important. Recurring cost is less. The cost of electricity is much less than cost of fossil fuel, cost of petrol. We then get into vehicle auxiliary, and also why is electric vehicles preferred choice today. This is the first thing that we will like to do. We'll then contrast petrol pumps and charging stations. Petrol pumps is where you go to get your petrol filled so that the vehicle can run. That's a source of energy. Charging stations is where you will go to get your batteries, or sometimes called vehicles, charged, because from that electricity only you are going to drive the vehicle. So we will talk about petrol pumps versus charging stations, and therefore of course we will talk about battery energy, battery power and range. That's what we'll start with in overview of electric vehicles. After that we'll talk about EVs in India. Why is there so much interest in electric vehicles in India? Suddenly everybody is talking about it, in spite of recent fires. In fact, even the recent fire in batteries are being talked quite a bit, because electric vehicle revolution is happening. It is coming. Everyone knows that we are going to move away from petrol vehicle to electric vehicle. As petrol starts costing more than 100 rupees per liter, electric vehicle is obvious option. We'll talk about both the economics as well as what else is driving that. We'll then get into what is the key bottleneck in electric vehicles. So if there is so much interest, why not switch to electric vehicle? What prevents us from switching? And we'll see there are problems, and we'll discuss these problems. We'll then introduce a very interesting concept: energy density of petrol versus EV battery. Petrol is what you will store to drive a vehicle. Electricity in a battery is what you will store to drive an electric vehicle. But the energy densities are very different. Energy density of petrol is very low, so you require a small tank, low weight. For battery, weight is high, size is high. That will be your first bottleneck. We'll deal with that. And then, since battery is mostly dominated by a capital cost, we are going to talk about how do you convert that capital cost plus operation cost into my cost per kilometer. Because finally, what I am interested as a user is kitna deti hai, what is my cost per kilometer? If I drive electric two-wheeler or a petrol two-wheeler, or electric four-wheeler versus a petrol four-wheeler. So that is what we will learn to compute. Of course, we will soon learn that India's vehicles are primarily two-wheelers. Our 80% of vehicles are two-wheelers, and therefore we will specially focus on two-wheelers. So can our electric vehicle policy also be in accordance that get two-wheelers shift from petrol to electric at the earliest, and that's what is happening. Excel in minimizing energy usage per kilometer. Why? We'll learn. We'll talk about battery is a dominant cost. What is the strategy to reduce the battery cost? And we'll introduce that of course you can use battery charging, but can you also do battery swap? That is a new concept that we have to introduce. It's similar to what you use with LPG gas cylinder. Nobody comes and fills your gas cylinder at your home when your gas cylinder runs out. It just swaps. It brings a filled gas cylinder, places it in your kitchen, remove the empty one and take it away. Can we do the same thing for electric vehicle? We don't talk about charging the battery. Somebody will bring a charged battery and install. When the battery charge gets emptied, somebody can remove that battery and put a new battery. That is called battery swapping. We will discuss how battery swapping can be used. It's a very, very interesting concept. Say, becoming significant in India. We will then talk about a very important issue. Now, in a petrol vehicle, there is a petrol tank whose life is very long. Even if other subsystems of a petrol vehicle starts deteriorating, by and large, nothing happens to fuel tank. Not so with battery. Battery, which is a container of electricity equivalent to a petrol tank, its life is limited. We will talk about battery life and charging and swapping infrastructure. We will then get into where will we get lithium for batteries, because this is a big concern. The batteries are made using lithium, and do we have lithium in India? We will get into that. We will get into what is called battery pack design. Battery life and charging, as I told you, sorry, that is somehow coming second time. We will talk about second life of batteries and recycling of battery cells. And after that, as I told you, we will get into all the EV subsystems and also talk about what, not just today, but what are the future technologies that you need to watch out for. That's a chapter 1. That itself will be about 4 or 5 hours, and we will do that fairly comprehensively. But this is the introduction, and there are 2 subsystem part of it. We'll do this. And then we'll get into vehicle dynamics. And as I pointed out, the vehicle dynamics for a petrol vehicle, electric vehicle is very similar. Equally applicable to internal combustion engine vehicle or a petrol vehicle as well as electric vehicle. And we'll start by computing various forces acting on a vehicle in motion. When a vehicle is moving, what are the forces that are going to act on it? And we'll define what is called aerodynamic drag, rolling resistance, uphill resistance, what is the force required when you go uphill, and what is the force required for acceleration. There are 4 primary forces that will be acting. Aerodynamic drag, basically when you are riding a vehicle, you are pushing some air away. That air will try to resist you. That will require certain amount of energy, and we will talk about that energy and power. Rolling resistance, when tires are moving on the road, depending on the kind of road, a certain friction and certain amount of energy loss will be there. We will talk about that. When you try to climb up, a certain energy will be required, potential energy. And then whenever you accelerate, force is equal to m into a. You will always require some force. You will require some power to drive that. We will compute all of that. We will calculate traction power applied to move the vehicle. And then we will come back to force and torque required for acceleration. Acceleration is something very, very important. We will talk about that. Then, having done this basic, what is a drivetrain to provide adequate force and torque at different speeds to overcome all the resistive forces and provide right acceleration. And we will do this computation for 2-wheelers in detail. We will do this computation for 3-wheelers. We will do this computation for 4-wheelers. We will use simple Excel sheet to do this computation. And that will give us at what speed we can take, at whatever speed the vehicle, we can decide on acceleration, deceleration, what is the force and torque and energy required. All this we can compute, and we will do this computation. And that will bring us to a drive cycle. How do you how is it typically a vehicle is driven? How long it is being driven at 70 km per hour, how long 60 km, how long 50 km per hour, what is the acceleration used, when is deceleration, how many times do you stop, how many times you accelerate, how many times you decelerate. It varies from drive to drive. And yet there will be certain standard drive cycle, which is a typical drive cycle that a vehicle will use in a specific location. In a hilly location, in a flat location, it becomes a drive cycle for that locality. Now that is the average usage, by and large the usage, drive cycle. It is standardized. It is standardized because now the vehicle performance will be measured against that drive cycle. If different vehicles, petrol or electric, are driven as per that acceleration, at that speed, with that torque, what is the energy required? We then comes to a very important concept of regeneration efficiency. Now this is something very specific to electric. Normally when we go down a hill or down a slope, energy will be lost. We will be actually braking most of the time. That braking energy is lost in a petrol vehicle. Not so in electric vehicle. While braking, I can actually make my motor into a generator, and it can generate electricity and charge the battery instead of drawing power from the battery. Instead of drawing electricity from the battery, I am actually charging the battery. To that extent, my braking does not lose the energy. Of course, it will lose some part of the energy. Part of the energy is recovered back, and that is called regeneration efficiency. I do it using in the slope. I also do, suppose I am speeding, I am running at 70 kilometers and now I have to slow down. I will apply a brake. Can I make it regenerative? That much energy I will not lose. In petrol vehicles, you just lose that energy. Now that's the important component, because I can recover that energy, charge the battery, and to that extent my efficiency goes up. And then we'll come up with this concept of drive cycle and energy usage per kilometer. How much energy is used, how much electricity is used, how much petrol used per kilometer of a specific vehicle in a specific drive conditions. And as I pointed out, we'll use spreadsheets to compute traction force, torque, power, energy for different drive cycles. And this will also bring in that you need to make the vehicle efficient. First, you design efficient motors and controllers. Use good tires to reduce rolling resistance. You do vehicle design so that aerodynamic resistance gets reduced. Again, increases the efficiency. You to reduce the weight, that enhances the efficiency. You require less energy, less watt hour per kilometer. If you improve your regeneration and not lose energy during deceleration or coming down slow or slope, to that extent your efficiency increases. We will talk about all this and its impact on watt hour per kilometer of a vehicle. That is on vehicle dynamics. And that will bring us to the third part of the course, the last part of the course, the electric vehicle subsystem design. We'll once again talk about ICE versus EV. What is the performance driven by motors and controllers and battery. We'll certainly talk about at what speed, what torque it is being used, and what is the power requirement, and compare with petrol vehicles and electric vehicles. and then we will get into EV drivetrain, train and subsystem. We will define the vehicle performance parameter. We will talk about fixed gears versus changeable gears. What happens? Most petrol vehicles have changeable gears. Electric vehicle can have changeable gears, but you can also design good motors and controllers such that you don't require changeable gear. A single fixed gear is enough. That improves your efficiency, reduces your cost, wear and tear gets reduced. So we will talk about it. And I'll tell you, the motors and controllers that we are designing today will keep on improving such that tomorrow changeable gears will go away, not required. We'll then not only talk about, we'll also get into thermal and mechanical requirements of motors and controllers. They get heated, motors and controllers and batteries, all of them will get heated. There will be vibrations. What are the requirements? How do you essentially design your subsystem to handle that thermal and mechanical requirement? Similarly, we will talk about battery power requirement, battery energy requirement, range requirement, all these things. We will talk about a concept of auxiliary battery. And then all kinds of EV auxiliaries. Electric vehicles have all these units, again taking power from battery, and therefore we will talk about vehicle control unit, we will talk about lights, wiper and window motors, communication sensors, converters, air conditioning, heating, etc. This together will be my part 1 of the course, and that overview I will do to start the course. It will take the first 5.